Good morning, everybody. Thank you for joining me today. Thank you for watching, whether you're watching live or you're watching the recording. I appreciate you watching today. Thanks for joining me. So today we're going to talk about Python, and I'm going to want to spend a little bit of time in Replit. Actually, I'm going to want to spend most of my time this morning in Replit, just writing you code and showing some different things here. I kind of want to do more demonstration today than just kind of talking. So going to spend a lot of time writing code this morning. That way we get more accustomed with using the platform of Replit and get a good idea of what we need to be doing when we're writing our code. Of course, there's also a lot of other material in the module for you to be able to get what you need to complete the assignments. You can basically do everything without me. So, just having me there as support and to add on to things. That's the big goal, as always. Before we get started today, just want to throw out that there is an open house this evening. If you want to stop by the college and see what's going on, the college is having an open house this evening from, I want to say 4:30 to 7:30. That sounds about right. Got a lot of different college resources, things going on. If you're a first-time student, if this is if this is like the first class you're taking, or the first classes you're taking are this summer, or if you've just been online in the past and you want to know what we've got going on here on campus, feel free to come through. I'll be there this evening, at least for a while. May or may not be there for the whole thing, but I'll be there representing the esports program here at Cleveland Community College. You might not have been aware we had an esports program, which is why I need to get out to these events and promote it. But we do. So I'll be there, and a lot of other resources and things will be here for you if you want to stop by. It's going to be primarily out in the courtyard of the Advanced Technology Center, but I'm sure they'll have signs and wayfinders and things to help you get where you need to go if you want to stop by this evening. So as always, as we are going through our live class today, if you have questions, if questions arise, if you want to see something, drop it in the live chat, send me an email, send me a Teams message. I am monitoring things, so we will get your questions as quickly as possible and try to get them answered. If you're watching the recording, feel free just to send me an email or a Teams message just whenever you have a question, and I'll do my best to answer them for you. But we're talking about Python today, and this is extending on what we're kind of talking about last week when we were talking about, kind of thinking like a programmer. So now we're trying to take some of those things that we discussed as we were examining how we kind of think like a programmer, and we were doing the block logic, and we were seeing kind of how these different puzzle pieces put together. And now we're going to kind of take that and convert it to an actual programming language, which is why we use Python, right? When I was coming up learning how to program, it was really popular to use teaching languages to teach people how to program, right? There were some languages that were specifically used for teaching people how to code, and they weren't really used for anything else. Right, and that was kind of the popular wisdom of the way kind of things were done from, 70s, 80s, basically since, programming kind of existed, is that we teach you on something and then you kind of expand out and figure out real world things from there. And so as I was coming up learning how to program back in 2003, right, which in my mind doesn't seem like that long ago, but it was 20 years ago. we used a programming language called Turing. And Turing was a Microsoft-specific teaching programming language that's not used in the real world. Here, when we're starting to teach people how to program now, 20 years later, one of the things that we've kind of latched onto as a good idea for teaching people how to code is to use a programming language that people actually use. And so that's why we use Python. I mean, if you look at the top 3 languages in use in the world, they are basically Python, Java, and JavaScript in no particular order. I think JavaScript is actually the most used programming language in the entire world. So Python's in heavy use out there, and it's in heavy use in a lot of different areas, which is something that I tell people a lot. Like, you know, you don't necessarily have to be a computer scientist to be useful as a coder, right? Or to be useful as a programmer. You know, if there's an industry that you want to get into, that you're interested in, nowadays they need programmers, right? They need people who can write code and program and write scripts and process data with code. Right? Because basically every business nowadays at least has a business intelligence analyst or something of that nature who is able to take big sets of data, process it, get information from that data. And nowadays we do that with code, right? Because if we were to try to take enormous sets of data and do all that by hand, or even do all of that in Excel with just basic Excel formulas, it would take forever. So we use code to parse data, business intelligence, big data situations, right? And oftentimes that's Python that's used to do that. If you look at different industries have specialized programs for them that oftentimes people need to be able to run or build or use or work with, right? So if you want to work in the automotive industry, somebody has to write the software that does the OBD2 diagnostics, right? And as things kind of change there, you need new software. If you want to get into the healthcare industry, I mean, the vast majority of the healthcare industry now is software. You know, being able to read levels through a sensor and being able to take that sensor data and process that data into information. Education, right? We use a lot of data at the college to be able to make determinations on things and being able to process that data. And then when you see things like Blackboard, the interface that we use to have an online class just in general, right? Somebody had to build that. So, I think oftentimes we kind of shoehorn ourselves into the way that we think about IT careers. And, we think that, a programmer kind of works at like IBM or Microsoft, and they, just build these certain things. And that if you don't want to work for a big tech company, then you maybe shouldn't be a programmer. But as it turns out, it's way, way different. So as we're getting started today, I just kind of want to define a few terms for us as well. First of all, here I want to just talk about just what exactly is a program. And so I'm just going to take a few slides here just to sort of demystify some terms, because I do think that's important to just reiterate this. We have a big definition of what a program here is, and a small definition, right? I mean, that's basically what my 2 bullet points are, is a bigger definition and a smaller definition. And the bigger definition here is of a computation. So we say that a program is a sequence of instructions that specifies how to perform a computation. So we can kind of think about a program like a recipe. Right, a program's like a recipe. I'm giving my computer a sequence of steps, and it is taking that sequence of steps and it is applying it in the way that I tell it to do to perform a computation. And this computation, right, this all goes back to why we tie everything together here in these first few modules, right? Because a computation could be anything, right? We tend to think about computations in terms of math, but since basically everything that a computer does is math, because, binary and all that kind of stuff that we've talked about over the last several weeks, a computation can be anything. It can be displaying a picture, doing a math problem, showing a video, replacing text in a document, right? Just basically anything. And there are different types of computations that we talk about here. There are mathematical computations, but then there are symbolic computations. And that's what gives us the difference between, basically doing math and doing everything else within a computer system. Right, so we say that a program is a sequence of instructions, but one of the things that we don't really define here is what exactly is a instruction. And an instruction for our purposes is a line of code, right? Just a single line of code. So if we think about our program as a sequence of instructions, each line of code in that program is an instruction. It is one thing that I'm telling my computer to do. And one of the things that I like to talk about here is that while programming languages look very different, at the core, they're all the same because they all have a few things. Right? And some people break them down into 4. I tend to break them down into 5. Because I kind of take conditional execution and math and separate them out. Other people will refer to that in one item kind of as just evaluation, right? The ability to evaluate a statement, because when you look at math and you look at conditions, what's going on there is basically the same thing. It's just sort of a different equation. But I think it makes better sense to people to say, well, we can do math and we can do conditional execution, just than saying we can do evaluation. But in general, right, and that's where our IDE, or integrated development environment, which is REPL, that's where it gets its name, are these things, right? REPL, it's an acronym: read, evaluate, print, loop. And so we said evaluate here is going to be our math and conditional executions that I have in my 5. The read is going to be the input, right? The ability to get data from some source, whether it be a keyboard or a file or a network or some other device or whatever. So that's read. E is evaluate, so that's going to be math. Just being able to perform math and conditional execution, being able to check to see if something is true or false, like we talked about last week when we were looking at the block logic for conditionals. Print, which is our output. And so output basically means, being able to display data on a screen, save it in a file, send it out, send it over a network like an email or a FTP file share. And then loop, which we're calling repetition here. So we can look at being able to do the same thing over and over and over again. So input, output, math, conditional executions, and repetition, which we can also term as REPL, read, evaluate, print, and loop. So an instruction is going to typically fall into one of these categories. And these categories are going to be universal across all systems. So let's talk briefly just about what Python is. And so Python was created by Dutch programmer Guido van Rossum. I believe Guido van Rossum was one of your choices for historical figure from Module 1, although I don't believe anybody chose this individual. And Python is a high-level programming language. Now, when we say high level versus low level, what we mean is close to English, right? We talked about this briefly when we talked about programming languages and the history of programming in Module 1. So the closer a programming language is to English, or just a language that people speak in general, it is said to be high level. So high level is closer to English, and especially when we get to writing Python, we see exactly what we mean when we say closer to English, right? Because Python uses a lot of sort of English phrases that we can just read as English versus seeing it as symbols and code and all this stuff. And the lower level is closer to computer language. It's closer to binary, machine code. When we think about lower level programming languages, nowadays we typically think about something like assembly, right? Which is much more challenging to start to write. And things of that nature. Now, Python is open source and community driven. One of the things that I usually like to do when I talk about this is I like to talk about the Python source code. Because we can actually go online, go onto the internet, and see the Python source code. Because here it is. This is the Python source code on GitHub, GitHub being a code repository for people to store code, people to collaborate on code. We actually talk about how we use GitHub in one of our courses here. And if we, dig down into this, we can actually see the code that is used to make code, the code that is used to make Python. All right, so I can go into some of these folders here. I can see the different files. And I can see that Python is written in C. Right, we have a lot of C files in here that make up the backbone of Python. And so when we think about higher level and lower level programming languages, in that sort of way, right, we think about this fact that nothing can kind of exist on its own, and that's why we have to have both higher level and lower level styles of programming languages. And as we've sort of progressed over time with programming languages, we've been able to make them higher and higher levels because it's sort of like if you've ever seen that like evolution chart, right, where it goes from just some sort of ape to person. Right? Our lower level programming languages, assembly, things like that, they start to bridge this gap between human language and machine language. And then we're able to write another programming language that calls on this other programming language to do things. And so it gets a little higher level, it gets a little higher level, it gets a little higher level over time, right? Programming languages sort of evolve and build on one another. To get what we have in the modern day. So, whenever you're writing in a programming language, especially in 2023, you're not just using one programming language, you're probably using 3, 4, or more programming languages. You're just writing code in one of them, which is interesting. So it's open source, which means that anybody out there, if there are errors or there are features they want to add, they can add them. That also gives us the oversight to be able to, see what people are putting in the code, make sure it stays clean. Python's also considered to be a batteries included language, which means that a lot of the modules that you'll need to do like extra stuff are included. So there are certain things that you don't necessarily need by default that can be imported in as a module just to kind of keep the size and the memory need for a program down. One of the criticisms of Python in general is that it is, slower. Which really, when we're talking about programming in the way that we do it, what really does slower mean? It gets to this point of nanoseconds, right? But if you look at, say, coding competition sites, which those do exist, right, where people try to find efficient ways, the most efficient way to write code, you typically see things in C and Java run a lot faster than you do in Python. So Python's already kind of slow, and if all of these extra modules were included by default, it would just get even slower. So they are in the code base, but they only are utilized if you import them. For our purposes in this class, we won't need any of those. We're just going to use the standard base Python. It's also dynamically typed, which you can write statically typed Python. But it's dynamically typed, so you don't need to worry about typing, data typing. I mean, we will a little bit, right? Because we will have to do something that's called type casting. Just based on the way that, things are kind of done. But if you look at C and C++ and Java, these are statically typed languages, which means that when I create a variable or when I create a function or when I create whatever, basically, I have to make a promise to my computer that the data that results out of it will be a certain type. With Python, I don't need to worry about that. With Python, I can just create a variable, and that variable can just be what it is. Right? It can just be a variable. And it can hold any type of data. It can hold a string. It can hold a Boolean value, a true or false. It can hold a number, which we call integers, or floating point numbers, which is a decimal number. Right? All sorts of stuff. And we already mentioned that Python is widely used. It's easy to understand, right? It's a very, it's a language that's very close to English. It's widely used. And, if we can get the basics down with something that the syntax is a little bit easier to understand, then as we're moving into more challenging syntaxed language, it becomes a lot easier, right? One of the things that I talk about a lot is the fact that, when it comes to programming, there are basically two different things that we're looking at here. We're looking at syntax, and we're looking at logic. And so when we think about the syntax, we're basically thinking about how we write things. And so we can think about it like grammar rules. Right? We learned in English class that we have a certain set of grammar rules that, require us to do certain things as we write sentences, right? You capitalize the first letter, you put a period at the end of the sentence, you put commas in certain places, you capitalize proper nouns, all those sorts of things, right? When we're talking about syntax, that's what we're talking about. We're talking about how we write things. And, as we've discussed, when we're doing this, we have to be very specific, very, attention to detail oriented, because our computer has strict guidelines of what it's expecting in order to be able to understand it. The logic, on the other hand, is more of I'm going to say why, even though I don't really know that that's a great way to put it. Maybe the what would be the better way to put it. Or maybe what and why. Right? Because we learn, as we learn how to program, we learn like, oh, if I'm in this situation, I need to use a loop. Or if I'm in this situation, I need to use a conditional. Or if I'm in this situation, I need to put this value inside of a variable so I can control it better. Or something of that nature. Right? So as we are learning, if we understand the logic better, the syntax is something that we can kind of work out. Right? Syntax is something that you can learn from a book. Whereas logic is, kind of understanding how you work through the problems. So there is that. And so I think from here, what I would just like to do is move over to REPL and start writing code. Let's have a little fun. All right, so after logging into REPL, you see something that looks like this, right? Mine probably has more stuff on it than yours just because I've written a whole lot more code in here than many of you probably have. Right, and I've written in a bunch of different languages, and I've worked on a bunch of different things. And so when you're creating a new REPL, we have this button here, this button here. So this create REPL button here, this plus sign button here on the upper right-hand side, or this button here in the middle that says create REPL. They all do the same thing. They all create a new integrated development environment for us to use. And REPL here uses a lot of programming languages. You can write a lot of different programming languages on REPL. So I think it is a good place to use to learn things. And even somebody as even as an experienced programmer, I use this a lot just to do testing. Right? I can come in here and I can do a quick proof of concept and I can fire something up and work it out in here and figure things out without having to run an environment on my machine or figure this out or figure that out. Right? It just makes things easy. And, another one of the reasons why that I really like to use it is just how easy it is for you to take it and turn it in. All right, so Python's here in my favorites. Probably won't be in yours. But if we look here through the templates, we can see there are a ton of templates with a ton of different languages. And a ton of different types of things here. And all of this, if you wanted to try to play with some of this stuff, especially after you're, going forward, going out of the class, it's here for you to play with. Like, it's free and you can play with it. All right, so I'm going to just type in search templates here, I'm going to type in Python. And it gives me a lot of options of templates. But all that I want is just the plain old Python template. Right, which doesn't really show up in the list here because it's in my favorite. So the one that we want for our purposes is the Python one here at the top. It'll give you the opportunity to create a title or it will auto-generate one. I'm going to call this CTI 110 SU23 Python. Just so I can have something unique here, and I'm going to create my REPL. Now, what's great here is it gives me an environment that I can use. I write my code here in the center. If I wanted to add other files, I can do that over here. We won't need to be doing that. You can just leave your files alone, right? When you hit this run button up here, it's going to look to execute the main.py file. So you don't have to change anything at all here. You can just start writing code. And then the output will show up over here on our right-hand pane. And you can customize this if you want it to look a little bit different. right? There is a little drop down here that can get you back to the home page. So that's right beside the logo icon here. There's a little drop down where you can change different things. If I click the name of my REPL here, that's beside that, it's going to give me some different options for this particular REPL. For this, I really, for our purposes, I don't have to touch this at all. And we can just kind of go with it. So the first thing that I do whenever I get into a Python program is I write what we call a shebang statement. It's called a shebang or a hash bang. And I open up every single one of my Python programs with that. And I do that simply because it's a best practice. Right? And what it basically does is it is sort of the first line of the code. If I have Python installed on my computer, and I have this whatever .py file on my computer, I can double click my .py file, and it can look at that shebang statement, and it can see, oh, this is a Python 3 file. I can run it in that environment. And so it'll just run it without the need to make it executable. That's the purpose of a shebang statement. So it's just a best practice. It's not really going to do anything to your code. You don't need it there for the purposes of replet or REPL here. But it's a good thing to have. So I will let's start off by adding that. So we're going to say hash bang, right? And another name for an exclamation point is a bang. Then we have our hashtag. So it's basically hashtag exclamation point or hash bang /USR /BIN /ENV space Python 3. Right. And that's going to give me my message to my Python that, this is a Python 3 environment. So if the Python 3 environment is run or is installed on this computer, you can run it. Now we can get into the idea of writing some code. And so I think what I want to do here, just to be able to kind of explain things while I do it, just to do a really simple example. Because I want to just do a really simple coding practice problem. Just so we can kind of do one. I mean, we can kind of do some other stuff here, but I want to be able to kind of work through one that does a lot of different stuff just so we can figure something out. And this looks like this right here probably is a pretty good one. That will do a lot of stuff for us. So what I want to be able to do is I want to be able to let's see here if I remember how I actually insert text here. Well, I'll just draw it out. I want to be able to write a program which takes a number and outputs the sum of all numbers from 1 to that number. That's what I want to be able to do. This is pretty simple programming problem that we can use to incorporate all of our tasks that we'll need. I want to be able to write a program that takes a number and outputs the sum of all numbers from 1 to said number. So let's kind of get us an algorithm going here. So, right, let's kind of work out what we need to do here. First thing I want to do is I want to get a number. So I'll need to be able to take an input. Then 2, I want to be able to get the sum of all numbers from 1 to whatever the number is. So from 1 to our number, get sum. Now, in order to do this, I can break this down even further. I'm going to need a loop that starts at 1 and ends at the number. And then each time I'm just going to add numbers. There should be an M there. Add numbers through iteration. And so this is going to use our loop. So if we say read, evaluate, print loop, right? This is essentially our one here is going to be our read. Here's our loop. We're going to need to do some evaluation, right? We'll have a conditional statement to make sure it is a positive number, maybe, right? Or make sure that it is bigger than 0. Add the numbers together, and then we just print the result to the console. So fairly simple. Right, so the first thing that I'm going to want to be able to do here is I'm going to want a place to store the value as it's being added. Right, so I'm going to create a variable here and I'm going to call it result, RESULT. In Python, I can create a variable that is any name, right, as long as it's not one of the Python reserved keywords. It also cannot begin with a number or have any symbols except for underscores, right? These are our rules for variables. Cannot begin with a number, because whenever my interpreter sees a number at the start of something, it thinks, aha, time to do math, and so it tries to do math, but then there's nothing to do math with. It can't be a reserved keyword that's already in Python, so it can't be something like print or if or else or eval or anything like that. Right? Something that's already being used elsewhere in Python, it can't be that, which I believe there are a list of those terms in your module. And the only symbol that you can use in it is an underscore. right? So in this case, I'm going to take result and I'm going to set it to 0. Because this is just going to be our container, right? One of the things that we talked about last week is that we said that a variable is a container that can hold data. We can put data into it. We can take data out of it. So what I've done right here is I've created a container called result. Put a box. Got myself a box. Put myself a label on it that says result and put a 0 into it. And I can take that 0 out and I can replace it with anything. That is a process that we call in programming reassignment. So what happens when I give a value to a variable, that is called a assignment, and when I put a new value in there, that is called reassignment. All right, simple. I'm also going to need to take an input. And so what we want to do here is we want to create a variable that's going to hold our input. So taking inputs in Python is probably the easiest programming language to take inputs in. Right, so I'm going to call this user underscore input, and I'm going to set that equal to the result of our input function. Right, so we have a function here, it's called input. This is built into Python. I know it's a function because it has the parentheses right after it. That's how I can tell that it's a function. We don't really talk about functions for Python here. We do talk about what a function is when we get to JavaScript a little bit, I believe, because we kind of have to. But a function is basically just a block of code that does a certain thing. So this is a block of code that somebody has already written for me that allows me to take an input in Python. And so in between here, I enter in a string. And I know it's a string because it has quotes around it. And that string is the message that I give to my users. Enter a number. Just like that. So now if we run this, right, we'll see in our console, it'll ask me to enter a number, and it will wait. It will wait on me to type in a number and hit enter. And when I hit enter here, since we don't have any other code here, it's just going to kind of take that number and throw it away. So the only thing that we should expect when I hit enter here is to see this stop button turn into the run button. Like so. Right, because it's not doing anything with that number. But what it is doing is it's taking this value and it's putting it into the container with the label user input on it. And so now what I can do is I can start to do stuff with this value. Now, there is a problem here. Right, and it's basically the only time that we need to worry about typing with where we're at, data types with where we're at in Python, is when we are looking at an input with where we're at. Because every single input that comes back through an input function in Python is a string. And you can't do math with strings, right? A string is where we get those ASCII values that we saw, when we were talking about binary previously. Right? The ASCII value of a character is a representation of that character. So when my computer sees a string of 1 versus a 1, it sees two very different things. When it sees the integer 1, which is the second one here, which is just the number without quotes, it sees something that can have math done to it. It sees a number. When it sees a string, then what it sees is just a visual representation of a character. So it sees the visual representation of this character. Which is not the number, and you cannot do math with it. Right? So if I were to come in here and run the type function, So if what I wanted to do is I wanted to print out a result, so which we can use our print function for that. Makes it really simple. And I do talk about the print function in the module. I can use the print function. That's what takes items and puts them out to my console. I can use my type function to check to see what the type of something is. And so when I check the type of the value that is inside of my user input container, we can see what it tells me. Right? So I enter a number here and it tells me that that is class string. So that value as it is not something that I can do math with. Now what I can do is I can take that value and I can do what we call typecasting, which is where I change it from a string to an integer. And in this case, we use the int function. And so I can wrap that around my input function, and that will take whatever value is input, right? It's going to work. It's basically going to work from inside out, which is what we see here. So it's going to start by outputting enter a number as a message to our user. It's going to take that number and it's going to return back a value that is going to be a string, because input functions always return string. But then it's going to take that and convert it to an integer, which is something that we can do math with. So now if we run this program again, we shouldn't see class string. On the output, we should see class int when we enter in something like a 10. Right? Which is exactly what we get there, class int. And so now let's go ahead and write our loop that will get us to add the values together. Right? We're adding the values together from 1 to whatever our user input value is. Right? And so for this, we're going to be using a simple for loop. So I'm going to start with the word for. And next thing we're going to have here is a variable, and you can basically use anything as your variable here. Something as simple as a single underscore works. I typically use the letter I for iterative or iterator, because that's what one pass through a loop is called an iteration. But I want to get the I in the range of 1 to user input plus 1. Right? And so let's talk about why we want to do plus 1 here. When I use a for loop, it goes up to but does not include the last number. Right? So since our prompt here was to add all numbers from 1 to whatever number our user inputted, then we would have to be able to include that user input number as well. Now, there are other ways that we could do this, right? We could just add it on as an option. But, I mean, this is just a little bit simpler. You just say, go one more, right? And it's going to make it more universal. Less code. And then at the end of this, I put a colon. And whenever you see a colon at the end of a line of code in Python, that means it has other lines of code that belong to it. So there are going to be other lines of code that belong to this for loop, or that go inside of this for loop. Like when we looked at our Scratch, when we looked at control structures, and we looked at our loop, we saw that there was this space inside, and that's where we put the instructions that belong to that loop. And so that's essentially what this is doing here. We're giving a space for the instructions that belong to this loop. And so this instruction is relatively simple, because I'm going to take whatever value is in result, and I'm going to add to that result plus I. Right, so notice here I have this space here. This is a tab. So we have my tabbed space here. So in order to put items inside of an item that has a colon, I add a tab at the beginning of the lines that belong to that statement. And this is where things can kind of get a little sketchy in Python, right? Because you might have a for loop that belongs to an if statement, that belongs to a function, that belongs to a class, right? So the more levels deep you have of something belonging to something else, the more tabs over you have to do. Because this belongs to this, but then this needs to still have its ownership, so we need to tab over again. So for each layer deep of the tab, it's belonging to something else. And we'll show an example of that because we're going to put this in a conditional statement here in just a moment. Right, so for I in range, one to user input. So that's going to do this one time for every number, 1 all the way to my user input. So if my user input is 10, then it'll run this code once for 1, run it again for 2, run it again for 3, run it again for 4, run it again for 5, run it again for 6. And we'll do a little something to show that here in just a little bit. And when I'm done with my code and I want to back out of anything that belongs to something else, I can just hit backspace, right, and make it go backwards. So if something doesn't belong to a statement with a colon at the end anymore, then I can hit backspace and go back a level. So in this case, I'm going to print result to the console. And so I'm going to run this one time so you can see it happen. And then I'm going to add a line of code here that's going to show you some things, that's going to basically show you what's going on here. So I'm going to run this. I'm going to enter my number. I'm going to enter a smaller number this time. All right, like let's say 5. That's one of the things that I like to do while I'm programming is I like to start off by entering a smaller number, something that's easier for me to read. So we might even go with something like 3 here so that I can do the math in my head and get the output. And then if the small number is right, or if I can do a couple little tests with a couple small numbers, and they're right, then I can feel more comfortable and feel more confident when I'm doing big numbers and assuming they're right. Right, so if I enter in number 3 here, I should get 1 plus 2 plus 3, which is 6. So I should get 6 as a result. And I do. Right, so what's happening here, and I can actually add a line of code to this so you can see it. We can print I and result. So now we can see what happens through each step of the way through the program, right? Because it's going to do this thing, and then it's going to print out the current value of I and the current value of result each time through the loop. So if I run this and I write something like 5, first time I is going to be 1. Second time I is going to be 2. Third time I is going to be 3. Fourth time I is going to be 4. Fifth time I is going to be 5. Sixth time it's not going to run because at that point it's gone up to I plus 1, or user input plus 1, which is 6. So it's going to stop and it's going to skip down to that and it's going to print out our result. So each time it's going to show us as we're going through the loop the value of I and the value of result on that particular iteration. And there we see it. All right, so on our first iteration, when I is 1, let me zoom into this. On the first iteration where I is 1, we can see it added 1 to 0, and so it gave me 1. And result became the value 1. On the second iteration, where I is 2, it added 2 to the value of result. From the previous iteration, the value of result is 1. So 1 plus 2 is 3. So then that result of 3 plus 6 is, or plus 3 is 6. That result of 6 plus 4 is 10. That result of 10 plus 5 is 15. And so it gives us 15. So now we can kind of see what's happening as we go through our loop. And that's a good way to write some tests too. Now let's say I want to check to see if this number is positive or if this number is 0. Right, because if this number is 0, I should be able to do something, and if it's not 0, then I should be able to do something else. So I'm going to write a conditional statement. I'm going to say if user input is greater than or equal to 1. And we're going to put a colon there. And what does that colon mean? That colon means that there are lines that belong to it. What are the lines that are going to belong to this statement? The lines that belong to this statement are going to be this for loop. And now this result here still belongs to this for loop. So I need to go again. Now I can use an elif, and I can say elif user input is less than 0. Right? So if it's less than 0, then it's going to be a negative number. Now, one of the great things about using Python as a dynamically typed language is I can take something and I can simplify it by, if I need to, putting a string inside of a container that previously held an integer. So in this case, I can change the value of result to equal negative number as a string, right? So I don't have to do anything fancy with it. So now when it gets down here to print result at this point is negative number. So now I have my if condition, which handles every number from 1 to infinity. My elif condition, which handles every number from -1 to negative infinity. And 0 is kind of, so that only leaves me with 0, and I could write an else condition for that. Right? We can use an else condition that basically covers all other possibilities. But in this case, result just stays 0. So we actually don't need that. So our if statement here covers everything from 1 to infinity. Our elif statement here covers everything from -1 to negative infinity, which means the only thing that's left would be if our user input was a 0, then it would just print out 0. Right? So now we see something, now we see a program here that reads, that evaluates, that prints, and that loops, right? We're getting that REPL. We're also doing evaluation here with our arithmetic operator and here with our elif statement. So that's 3 instances of evaluation, 1 instance of reading, 1 instance of printing, 1 instance of looping. Right, so now if we run this, we've used our conditionals here to allow our program to make choices. So if I enter 0, I should just simply get back 0. Right? If I enter a number like 5, I should get back 15. And if I enter a number like negative 12, I should just get back that it is a negative number. Just like that. And so now that I'm comfortable that what I have here is working, I can enter in a big number, like say 74, and get 2,775. So in just a few lines of code here, I was able to write a program that could take every number from 1 all the way up to whatever big number I want to take it to, and add them all together. And I also included cases for if that number is a negative number, and essentially a de facto case to where if that number is just 0. Right? That's going to make it even more efficient. Now, there is one cool thing, right? And I think I'm going to wrap up here. But while I'm kind of waiting on your questions, I'm going to explain the concept of the modulo. Because you will need the modulo in order to complete your... Do you need the modulo? No, you don't need the modulo. You don't need to worry about the modulo. Because it's just greater than, less than in your lab assignment, not even odd. So you know what? We won't even get into the idea of the modulo here. We're just going to keep it simple. I'm not going to complicate things too much for you. So this will be where we go ahead and wrap it up. If anybody who's here with me live has any questions, you can feel free to send them in. Whether you want to drop them in the chat or you want to send them in an email or a Teams message, please do so. If you come up with if you might come up with a question later, feel free to email me or Teams message me. This is a more complicated example than what's being expected from you in the lab assignment. You just do have to use all of these things: the read, evaluate, print, and loop. Just the logic here is a little more complicated than what's required of you in the lab assignment. So hopefully you can kind of take this and expand on it and get what you need. We'll just hold for a second or two here just to... see if anybody has any questions. If you're watching the recording and you come up with a question, or you think of a question later, you can always email and our Teams message and send it in. I will include this. I will include the link to this, right? Because all I have to do to get the link to this is just take this URL from the URL bar here at the top, copy it, and now I'm ready to use it anywhere. It's just as easy as that. So I'm going to include the link to this file with the recording today. And so this is also a link that you could include. You could submit your link like this as your lab, for your lab assignment. You could just come up here to the URL bar, copy the URL that's here, and send it in. Another option is to use the invite and to give me a join link from here, but it's a little more complicated. Right, since this is a public thing, then I could just take this and copy it, put it in there. So since I'm not seeing any questions, we'll go ahead and wrap up here. If you think of one later, send me an email, send me a Teams message, and we will try to clear things up for you. But that is all that I have for you for today. Thank you for watching. We'll see you next time.